Hi everyone. So this video is kind of some review over what we went over on Tuesday and Wednesday of our class session. So we talked a lot about volume and finding the volume of specific figures, such as cubes, rectangular prisms, triangular prisms, cylinders, cones, and square pyramids. So we had a lot of things that we discussed in those 2 days. So let's review some of those definitions, which I have pulled up for you right here. So volume. That is the amount of space in a given container. So a way you can think about that is as if you were filling up a glass of water. So you pour water inside this given container, and as much as you can fill up is the amount of volume there is. So all the way to the top is the maximum amount of volume in that container. So that's one example. So let's talk about some other things. So base. The base of a three-dimensional figure is the surface a solid object stands on. So that might seem a little bit odd, but let's look at a couple of examples. So if we look here with this figure right here, our base in this case is a triangle because while it may not be resting on the triangle right now, if we go completely opposite that side, it has the exact same duplicate face that is also a triangle. So a base typically has there are two bases to every three-dimensional figure typically, and they're almost always parallel to each other. So I can't say that 100% of the time, but almost always, like 99% of the time, there will be two bases to a figure and they'll be parallel to each other, as in the case of this triangular prism or this cube right here. So let's continue on. The face of a three-dimensional figure is the surface that forms as a part of the boundary of a solid object. So in this case, if we look at, again, this triangular prism right here, this picture, if we look at our faces of this figure, we have a triangular face here, which coincidentally also happens to be our base. We have a rectangular base right here, which is great. We also have a rectangular base on the opposite side, so on this side over here, and then another rectangular base on this bottom piece. So in a triangular prism, there are 3 rectangular faces and 2 triangular faces. So in that case, there's 5 faces. So, and again, a face is the surface that forms a part of the boundary of a solid object. So, great. The vertex of a figure is the corner of any three-dimensional figure, and that's typically where 2 faces meet on this figure. So again, let's go back to our base, our triangular prism. If we look at this figure here, we have a vertex right here, a vertex right here, one right here, and if you look, this is where our rectangular piece meets our triangular piece. So that is where our vertices come in. A cross section is the shape we get when we cut straight through an object. It's like looking into the inside of something made by cutting through it. So you can, let's apply that to, let's actually look over at this section right here. So if we look at a cylinder, and if we were to cut this thing in half, the inside pieces that we're looking at just break off into 2 smaller cylinders. And so if we look at our cross section here, which is what we call this cutting, they are both circular shapes. Our cross section is this circle part right here. So it's that circle portion right there. Now if we were to take a peek at this triangular prism right here, if we cut this way, like they do right here, we're going to get a triangular cross section here. So that is one way to look at this. Let's say we were trying to cut along the halfway through the triangle. So let's say we wanted to cut this way instead of this way. What kind of shape do you think we'd get? Well, I'll tell you, it's going to look very similar to the base on your bottom of your triangular prism. So it'll be a shape that is somewhat smaller, but still similar to your rectangle on the bottom of your triangular prism. And if we were to do the same thing with this shape here, with your rectangular prism, if we were to cut it in half, we'd get another rectangular cross-section shape. So cross-sections are basically just cutting an object in half and looking at what that shape is on the inside. So basic definition. A prism is a three-dimensional figure whose two end faces are similar, equal, and parallel figures. So in other words, these are your bases. So your bases are two similar, equal, parallel figures, and their sides are parallelograms. So let's take a look at that for a second. So if we take a peek at this shape right here, first of all, this shape on top, what's that called? It's pentagon, yep. So this is the pentagonal prism. So if we look at our sides here, these sides right here, these are parallelograms. What shape does that look like? Rectangle. Rectangle should be flashing in your head. So a rectangle is also a parallelogram, but not all parallelograms are rectangles. So that's a key distinction to make here. So here is another example of a pentagonal prism. This one's a little bit different. If we take a peek at this one is a hexagonal prism, a six-sided prism. So again, if we look at this side length right here, that is a parallelogram or rectangle, whichever way you want to think about that. They're pretty similar. So prisms, they have two bases. They always have two bases. That is the key thing. Now, let's take a look at a pyramid. A pyramid is a three-dimensional figure with triangular faces meeting at one vertex. So, let's take a peek at this. We have our rectangular base here, or square base, whatever you want to think about this figure. It's all about perception. We have this square base here, and we have triangular faces on the side, right there. So, looking at this, they all come to the top and meet at one point. All of these faces excluding our base. So, what's important about a pyramid, the very key important distinction here is that pyramids only have one base, and that is it. There is nothing else. So, very important key distinction. So, let's take a brief moment and reflect on the difference between pyramids and prisms. So, when we explored our cross sections of pyramids and prisms, what did you guys notice? Do you guys remember? What happens when we cut a pyramid in half right here? What is our cross section going to look like in relation to what our original base is? So if we were to cut right here on this pyramid, how is it different than this base of our pyramid? What you should be getting is that our cross section is a lot smaller than our base. So that's telling you that as our pyramids move up to the top, our cross sections are gradually getting smaller and smaller. If we look at prisms, let's say I were to cut this prism in half right here. If we look at that cross section in relation to our original base, they are going to be the exact same size, regardless of where I cut. So if I were to cut right above the base, it'd be the same as the base size and shape. If I were to cut right in the middle, right here, it'd again be the exact same size and shape, and again, really close to the top. So that is one key distinction of our prisms and our pyramids. So I wanted to briefly discuss your assignment with you. So tomorrow, I would like you guys to create an infographic using Piktochart. And so I've uploaded the link here that you guys can easily access so that way you can create your account and get everything set up. I want you to use your school email so that way I have easier access to it. I also would like you to include the following information on your infographic. You need to talk about 4 of these 6 figures we discussed in class. So a pyramid, square pyramid, a triangular prism, rectangular prism, a cube, a cylinder, or a cone. So those are the 6 figures you can work with. For each figure, I want you to include a picture for that 3-dimensional figure. I want you to include a picture for the 3-dimensional figure's cross-section or the base. So if the base of let's say you chose a cylinder, the base of a cylinder is what? A circle, exactly. So I would want you to include what that shape is on your picture. And so I would also like you to input the formula for each three-dimensional figure to calculate the volume. And I would also like you to include the formula for each cross-section or area or cross-section or base of each of our three-dimensional figures. So include the formula for our three-dimensional figure, include the formula of the area for our cross-section or base. So the last and most important explanation or piece I want you to include on your infographic is the explanation for how our cross-section or base relates to our volume. So what part of our volume formula is connected with our area? So I want you to make that connection there. Here is the rubric for that. You guys can review this on your own. It's very straightforward. If you have any questions, feel free to send me an email, and I will be more than happy to answer those. So thank you guys.